All right. This is our last unit, functions operations. It should take 2 days. But the key thing in function operations, is that it's fun. Okay. Corn dog. Let's go to the next one. Even for me, that's a bad joke. We're giving you the Coles Notes versions here, like just running it down really fast rather than doing a lot of explorations, which the textbook has good ones in there, by the way. If you want to look at a whole bunch of stuff going on and just maybe get a better understanding, if you look on page 474, there's an investigation that shows you a lot about sums of functions and things like that. Before we should start, we should maybe just review what a function is. Like, what is it?
Something at the line doesn't go through twice.
Okay, so Alana says that vertical line test proves that it's a function if it only intersects it once. The big fancy definition, yeah?
Every something another has a specific.
Every input has only one unique output. So for every x, there's only one value of y. Okay, so you guys got it. You helped. Fantastic. If we were looking at sum of functions, if a sum of functions is something like this, h of x equals f of x plus g of x. If we add two functions, it's a sum of functions, and you get a new function. So if I had a function called f, added it to this function called g, I can get a new function called h. That's all it's saying. Now, there are more concise ways to actually write this. Okay? You won't probably see f of x plus g of x. You're going to see f of x equals f plus g of x. These mean the entirely same thing. Okay? So you'll probably see this one in green on your diploma exam because it's cool notation, basically. But f plus g of x is the same thing as taking f of x plus g of x. And we'll look more specifically in a few minutes here what that actually means. Let's look at the difference of functions, which shouldn't be a huge difference, or I shouldn't use the same word, shouldn't be that big of a change from the thing we just looked at. Okay? So, difference of functions. I forgot the word of. I was wondering who's going to pick it up. Lana did. H of x, difference of functions is just the same thing. If we have two of them, we subtract them. Not a big deal. This is what's actually happening, subtracting the two functions. And then it should come as no surprise there's a shorter way to write this. What would it be? Yeah, it's going to be f minus g of x. These mean the exact same things. Okay? Just take the two functions and subtract them. Good? Indifferent. Let's move on to the next part then. Okay, so here's our example. Given f of x is 2x plus 1 and g of x is x squared, we're going to look at 4, I think, questions on this. First thing it's asking us, if we have those two functions, I guess you should be able to determine that f of x is linear, a straight line, because, pardon? It's not squared. Good. G of x is quadratic like a parabola because it is squared. So a little background knowledge from grade 10 and 11. Now it says determine h of x if h of x actually equals f plus g of x. So if we were to look at that, if I was to say f plus g of x, we already talked about on the last set of notes there that it's the same thing as f of x plus g of x. We're just adding these two things up. So this addition is a little nicer. F of x was 2x plus 1. So I'm taking that function, 2x plus 1, and I'm adding it to the other function, which was x squared. Now you just have to simplify whatever's there. Since it's all addition, it's really nice. We're going to have x squared plus 2x plus 1. This is what h of x equals. Those two things added up. Not hard at all. We're just adding two functions together. Okay? So now it's saying, let's take a look at what happens when we sketch f of x, we sketch g of x, and then we sketch this new function h of x. So in your calculators, you're going to have to get this stuff out to clear whatever's in there, I guess. I just have to set this up from a different class, get this out. That was grade 11, shading. So, we're going to sketch the three functions. 2x plus 1, we'll put in y1. The x didn't pop up. Then the next one is x squared. And the last one are the two things added together. X squared plus 2x plus 1. And we're going to look at the three graphs. They're going to graph in the order that we put them in. So the first one, I need to change my window because I'm not seeing much of anything. So I'm going to go back to my standard window, Zoom 6. There's 2x plus 1. There's x squared. And there is x squared plus 2x plus 1. Are they different?
Yes.
Sure, and it says sketch them. So you need to include in your notes a nice little sketch of these guys here. And when they're in there, you should probably label what's what. That's f of x. If you drew three separate graphs, that's good as well. That's f of x. Let's say this one here, the green one. That was my g of x. And that black one was h of x. Now back in grade 10, we looked really simply what f of x basically replaced when we were doing functions. What did it replace? It replaced y. So g of x is still y. H of x is still y, just on new functions. So if I was actually looking here on taking f of x and adding it to g of x, basically what I'm doing is taking all the y values of the f of x function and adding them to the y values of the g of x function, and that gives me new y values for the h of x function. That's all we're doing all the time. Okay, so the question that was on your field test about subtracting them, we had to be subtracting our y values and our ranges to figure out where this graph would actually have gone. Okay, so there, we got the thing sketched. State the domain and range of h of x. So h of x is that black one here. What is the domain and range of it? Okay, so the domain, x an element of real, it's everything. The range, y is greater than or equal to 0. Just looking at the graphs. Great. One last question that I said we'll put here, D. Determine f of 4, g of 4, h of 4. Now that is really, we looked at it earlier in the year as well. We've been using this terminology quite a bit. We were actually trying to find out that f function when I put an x in at 4, the g function when I put an x in at 4, and the h function. So f at 4 would simply be 2 plus 4, 2 times 4 plus 1, so f of 4 equals 9. G of 4, that's 4 squared, so g of 4 is 16. Now if I look at h of 4, that's a little bigger, but it's 4 squared plus 2 times 4 plus 1. What did that equal? Equal 25, which brings us right back to what I was saying earlier. We're just adding that plus that to get that, because h of x was f of x plus g of x. So whatever I put in for those two should add up to the h of x. Make sense? Great. Let's look at another example then. Second example, same sort of thing. It might be. F of x equals the root of x minus 1. G of x equals x minus 2. My question to you, number one, I'm telling you they are functions, so they would pass the vertical line test. However, g of x is an easy one to kind of identify what kind of graph this is. What is it? It's linear. F of x is something we did take last unit. What is f of x? It's a radical. And Amy's making sound effects and moving her arms, and she's saying, "Chew." She's saying it's going to go "chew," like this. Perfect. So at least we remember that radical functions look like that. Now this is going on to say, let's find a new function h of x, and it doesn't have to be h, it can be anything, but we're just using h of x. If we subtract those two functions, okay, f minus g of x. So we're just going to, again, since it's our notes, just show us what's actually happening. F minus g of x is f of x minus g of x, which means you're going to have to be particularly a little bit more careful now with subtraction. So when we substitute things in, f of x is the root of x minus 1. We should subtract that, or sorry, substitute that in brackets. Yes. Minus g of x. That means in brackets, x minus 2. What would happen if we forgot those brackets? You'd be wrong, yeah. Why would we be wrong? Yeah, we have a negative right here that's going to end up changing the signs of the other function. So if I was to simplify this, there's nothing I can do with this radical. It's just the square root of x minus 1. Now it's going to be minus x plus 2. So if you forgot those brackets, you'd probably get minus x minus 2, and you'd be wrong. So this is h of x. We just subtract two functions. There's nothing else I can do. Now we got to sketch these three things. Okay, so in your calculators, clear what's in there, and put the three functions in. The root of x minus 1. The other one is x minus 2. And if you were good enough, you could use y1 minus y2. Remember doing that in reciprocals? We could be saying vars over here, y vars function. Say, take that first function, subtract it from the second function, or you could simply write in what we found out h of x to be, the root of x minus 1 minus. If I graph all three, here's the radical function, here's the other function, and there's my combination of the functions. Okay, so we're going to put these into our notes, because that is the next question, to sketch these. And I'll just use the same sort of color. This straight line was, I think that was the g of x, x plus 2. There's f of x. And that black one is h of x. So now we're trying to figure out the domain of all these things and the range of this stuff. The domain of this h of x function, h of x was this. It's plus 2, right? Yep. Plus 2. The domain is x an element of the real numbers in this case. Why not?
Because it's larger than or equal to 1.
How do you know? Alana's suggesting it's x has to be larger than or equal to 1. Because you can see the graph. Is that what you're saying? On your graph, you're noticing that? Okay. How do we get that algebraically, Amanda? We have a restriction. Right here is a restriction. What do we know about the square root of anything? Can't be
Negative.
less than 0 or negative. So I know that x minus 1, that radicand, has to be greater than or equal to 0. So if I simplify that, it turns out to say x has to be greater than or equal to 1. Either way, if you read it off your graph, fantastic. If you could do it algebraically, even better, because you have a little bit more understanding going on. Now here's the issue we've got. What is the approximate range of this? Which means it's going to be hard to nail down. How are we going to find that?
Less than
Where could you go to find it?
your table.
Go to your table and try to find the largest value of y that you can see, because we are saying approximate. Because you can see that h of x goes down.
1. Because then after that, unless never mind, just kidding.
You're looking at your x's, right? You got to look at your y's for range.
Wait, what? Which one?
the one that h of x is in, so that would be y3.
It doesn't go higher than 1.
So in our tables, and why is it not going there? Okay. So we have to look at 1 more over, y3. I'm getting 1, 1. Okay, if I go up, is it all negatives or errors?
Yeah.
I can't get up on there.
You go up
Okay.
with your x.
Oh, yeah.
But yeah.
Could I go a little bit? Let's go between 1 and 2. How do I set my calculator between 1 and 2?
What?
How do I set my calculator between 1 and 2 on your x? What do I do?
You go second windows
Second window.
and then whatever you want.
I'm going to say start at 1 because I could see it's 1 at both 1 and 2. And instead of going up by 1s, what can I go up by? Pardon? 0.5. I'm going to even go up smaller, 0.1s, to see if there's even incremental changes. So if I do that and go back to my table and then scroll over to y3 because that's where h of x is it bigger than 1?
Yeah.
Yeah? Look, 1.2, 1.247, 1.2477. If we had to give an approximate range, would this be, okay, y is probably less than or equal to 1.25-ish, because we saw it's 1.247. So we could say approximately it's everything less than 1.25.
So they wouldn't accept.
That wouldn't be big enough. No, less than 1. Because it actually, we can see it goes even bigger. Okay, I'm just going to write. Here are the few questions you guys got to work on in your textbooks. And
Everything.
page 483, 3, 4, 6, 7, 13. Some of them are simple, like here's f of x, here's g of x. What's f plus g of x? Okay, so you can do those. We've got a few minutes to do it before we move on to the next part. Okay.